Hello everyone and welcome to this video on A2A. So you might have been hearing the term A2A, agent-to-agent protocol around, but may not have really understood what it meant. So my goal is for you to leave this video with a full understanding of what A2A or agent-to-agent protocol means and be able to implement it in your applications as well. So you might be thinking, what is the A2A protocol? In simple terms, the A2A protocol is an attempt at a seamless communication protocol between agents. So regardless of the framework, vendor, or the model that an agent uses, the A2A protocol intends to be able to standardize that communication process. Now let's think about it this way. Imagine you're going on a hike with several other people and they all speak different languages. And let's say you're going on a hike in a fairly unfamiliar terrain. You need to communicate with these people you're on a hike with because you're in an environment where collaboration or communication is going to pay off. Let's say you need some water, you need some snacks, or whatever the case may be, and the person you're on a hike with actually has that. But imagine you don't have a way to communicate with them, or there's no understanding between you both. So you speak different languages, they speak English, you speak French, and you can't really make hand gestures because hand gestures are also a means of communication. That's going to be one hell of a hike, right? Now imagine the alternate scenario where you're going on a hike with people who actually speak the same language as you do, then communication is actually seamless. Now, come to think about it, if you think about humans as agents, then automatically does that mean the English language becomes the first truly successful agent-to-agent communication protocol? Just a food for thought, but it does make sense, right? Because you have this huge number of people all speaking English and they can communicate with each other and actually understand each other, right? And that's the whole point of the agent-to-agent communication protocol. But let's take a step back. Now, what's the problem that we're trying to solve with the agent-to-agent protocol in the first place, right? And the problem is, first of all, communication. Now, when you think about the agentic universe and how agents actually work, you have several different protocols and several different frameworks that agents are built upon. And these frameworks are dependent on what the manufacturer of that agent is, right? So you have LangChain, you have CrewAI, you have Google, you have Anthropic. All of these different vendors have their own frameworks which they use to develop these agents. And there's no standard communication protocol between all of theirs. And that's a core problem that has to be addressed. And then you have design time coupling, because if there's no consistent communication protocol on how you can assess the resources of another agent, then that means you need to do tight coupling when you're building or designing that agent. You need to have foreknowledge of what the agent can offer. You need to have foreknowledge of how to reach that agent and get a feedback from that agent. You need to have foreknowledge of the types of response that the agent provides you. And you need to fully have all of this context to be able to fully interact with that agent and get feedback. So those are some of the main problems when it comes to agent-to-agent communication. So put in simple terms, agents are everywhere, but then there's no standard protocol for how these agents should interact with one another. One agent is very good at doing one thing, and another agent is specialized at doing something else. But there's no clear communication protocol on how one agent can take advantage of the benefits or the specialty of another agent, right? And that's one problem you have. And due to the custom integration that's involved, because you have to have foreknowledge of all the nuances of another agent to be able to interact with that agent, that becomes a blocker as well. So this leads to a scenario where you have to hard code, glue code for every single agent that you need to interface with in your applications, because they're all built on different frameworks. So you might say, well, then how did agents communicate before A2A? Before A2A, you need to build custom REST API endpoints and custom implementations for every single agent that your agent needs to communicate with. So it became a huge pain in terms of managing. And that's why we have so many different strategies on how to communicate between agents all came into play at the same time. We had things like MCP, the Agent Communication Protocol, and A2A all come into the surface almost at the same time. Because with the emergence of agents in this agent universe, the need for communication or interaction became very apparent. So with A2A in an agentic universe, an agent can communicate with another agent acting as an independent entity at runtime. So one agent doesn't need to have the full context of another agent, access to its tools, its memory, its thought process, to be able to communicate with it. Agent can operate in a fully atomic or agentic patterns, being specialists at what they're good at and providing services that other agents in the agentic universe can take advantage of or interact with. So by having this open standard, A2A enables discoverability. So an agent is able to discover its environment, know what other agents, what their specialties are, using something we're going to talk about next, which is called agent cards. And then agents can also collaborate after discovering the environment and what's available in the environment. They can actually collaborate with one another. And then you have interoperability as well. So there's seamless communication between these agents that are built by different vendors and run in different operating models. They can all communicate due to the shared open standard. For example, you can have an agent developed by LangChain or OpenAI communicating with an agent developed by Gemini or ADK, and also have another agent communicating with an agent from Meta or Llama or Claude, regardless of who the vendor is or what the framework is that that agent runs on. With A2A, you can have the seamless communication because there's a shared understanding that says, this is how we're going to go from A to B. This is my specialty. If you need any help from me, this is how you contact me. And this is what I can do for you. And this is what my response looks like. Understood. So next, let's look at the core design principles of A2A. So A2A is built around 5 fundamental principles. And these fundamental principles are what enable A2A to achieve seamless multi-agent security or autonomy. A2A is built around these 5 core fundamental principles. And the first is to embrace agentic capabilities. So agents can collaborate as opaque black boxes. So if you remember what I was talking about one agent not fully being foreknowledged about the internal workings of another agent, right? So agents can operate as black boxes, especially in what they're good at, without having to share their thoughts, their memory, and their prompt templates or tool definitions with another agent, right? And this sort of preserves IP. If you think about it in a business use case where you have multiple different organizations, they all have their IPs, and they can actually release agent endpoints with agent cards that other agents in the same space or in other spaces can take advantage of without fully exposing their IP. The next core principle is built on open standards. So A2A communications in terms of security, in terms of the protocol for communication, all relies on battle-tested web standards. So it uses HTTP. JSON RPC 2.0, and server stream events, which are all protocols that already exist. So there's really nothing new being invented in terms of how these agents should communicate. Right, so there's zero custom protocol overhead. If you already understand traditional web standards, you should be able to work with A2A. And the third is secure by default because it adopts standard open API authentication mechanisms. So all 2.0 API keys in the header, if you require MTLS, bearer tokens, and all of that, all work with A2A because it uses traditional web standard protocols. So there's zero trust architecture ready out of the box. You just need to build in whatever authentication mechanisms you already used to. The fourth principle is long-running task support. So ADK is designed in a way that you can take a task And it sort of has this triage, right, where it knows if a task is going to take a while to complete, then it's a long running task so that it can occasionally publish the status of what it's working on to different webhooks or different clients who initiated the request, right? So it handles multi-step workflows, background tasks, push webhooks, and human in the loop approvals natively. So it also supports the use case where if a task goes into this phase where it requires a human in the loop, it goes into this waiting phase where a human has to provide an approval or resolve whatever blockade it is before the task can continue. So what this does is it enables or supports processes that take long hours or minutes or even days to complete without holding up HTTP sockets open, because traditionally TCP sockets can only last for that long, right? So they can last several hours or days, right? So in this case, you can have a single long running task using the A2A protocol consistently providing updates on the status of the task that's running over days or several hours without a break in communication. Because even if the TCP communication breaks, you have a webhook endpoint where the server continually provides an update to the client via its webhook endpoint on the status of the task that it's working on at that point in time. And we're going to see this as we go ahead in the demo, which we're going to be building in this video. And then the fifth principle of A2A is modality-agnostic. So what this means is it handles structured JSON, raw text, images, videos, audios, PDFs. This means you can basically work with A2A across different modalities of information, and you're not limited to just text responses or image responses. Irrespective of the type of data that you want to support, A2A actually supports binary attachments via paths, which you'll see if you look at the A2A specification. So next, let's talk about some of the building blocks of A2A. So A2A is comprised of several concepts that make up A2A, or sort of that makes A2A possible if you think about it that way. And the first you have is an A2A client. And the demo we're going to be building shortly, you see we have a client, a server, and a webhook. And these are all components of an A2A protocol. So we have the A2A client, and the client is basically an application or an agent that needs to get some information from an A2A server. So it does initiate the request to the A2A server. And the analogy here is a person making a phone call, it's a phone call to some cell phone tower somewhere that now routes their call to whoever they're trying to call. And then you have the A2A server, and this is an agentic system that exposes an A2A compliant endpoint. The application exposes an A2A compliant endpoint, then it can be thought of as an A2A server. And in this case, the analogy for this could be a department that's receiving the call that was placed by the individual. And then you have the agent card. So the agent card is like JSON metadata that's published by the A2A server that tells the people around or its environment what it's able to do, what its specialties are. So JSON metadata that's published by a server that describes the identity of the agent, the skills that it supports or what it can do, and the endpoint that's available for communication. So for an individual, you can think about this like an individual's business card, right? So if I give you my business card, you can see who I am, you can see my role, what company I work with, and you're able to tell how I can help you, right? And then the next core A2A building block is message. So a message is a communication turn between the client and the server. And the server, it's in a communication or a conversation. So that person making a call to our department, the information that they share over the call, that's a message. In the case of A2A as well, that's also a message, which is just a communication turn between a client and a server. And then the next A2A building block is called a task. So a task is a fundamental unit of work, right? Now remember earlier we talked about long-running task or long-running requests, where the A2A server setup determines that that's going to need to take a lot of time to accomplish. So in that case, the A2A server publishes something called a task, right? So a task is a fundamental unit of work. A task can have multiple states, and the states could either be submitted, it could be working, it could be completed based on the status of the task. And an analogy for this could be an assignment with a tracking number. So let's say the department gave the student an assignment, and the assignment has a code or a tracking number. That's a task. The next A2A core building block is called a part. So a part is the smallest unit of content within a message. So if you remember, we said a message is a communication term. A part will now be sub-tokens of that communication, or sub-tokens of that communication term. And this could be a paragraph in a message to send, if you think about the message as an assignment. And then you have, if you think about a message as an assignment or an attachment. The next core A2A building block is called the artifacts. So artifact is an output generated by the agent. So this could be a document, an image, structured data, or block of text. All of these could be artifacts in an A2A agentic system or agentic environment. The next A2A building block is called a context. And a context is just an optional or additional identifier that's attached to related tasks, right? So it's just like a way for you to attach additional information to tasks for differentiation reasons, or maybe because they all belong to the same project. And then finally, you have the extension. So the extension is a mechanism for additional functionality beyond the core specification. So this is if you want to build additional implementations on top of what A2A provides by default. Remember, A2A is just a proposal for an open standard of communication, but you can decide to take that a step further by optimizing or improving certain flows to further augment what's already provided. So next, let's quickly talk about the three core layers of the A2A protocol. And the first is the data model. So the data model is the shape of data exchanged between agents. So remember, A2A is a consensus or an open agreement or an open standard for how communication should happen. So this means there has to be some sort of agreement as to what the components of that communication should be, right? So that's the data model. And this includes the task, the message, which we talked about, an agent card, which is how an agent is identified, the part, which are parts of a message or an artifact, and then you have the extension. These are all parts, or these are all aspects that make up the A2A data model. And then the next layer is operations. This is where you start thinking about communication. So what you can do with that data. So in this case, as a client, if you have the data model, you need to be able to either send a message, you can send a streaming message, you can request the status of a task, you can list the tasks that have been submitted, for example. You can cancel a task and you can request an agent card. So by default, what a client in A2A ecosystem will do when it starts up is it sort of does a discovery process, which you talked about as well earlier. And that discovery process is how the client is able to discover the agent or A2A server card, and then it knows what functionalities the A2A server is an expert at and what types of tasks with examples that it can send to the A2A server to be able to have the server process it. And then finally, the third layer is called the protocols, which is the means of communication, so how operations travel over the wire. And in this case, we have multiple supported protocols: JSON RPC 2.0, HTTP, plus JSON or REST or gRPC are all supported. So let's look at what the lifecycle of an A2A task sort of implies. So what does it mean when we talk about an A2A task, right? So an A2A task can be in multiple different states, but then it starts somewhere and at some point it gets to completion. So the first state of an A2A task is the state of submitted, and this is when a task is received by the server. So remember, in A2A, a client calls a server and sends a request over the wire. Now, when the server receives the request, the task moves to a submitted state, right? So agent begins processing the task. Then at that point where the agent starts working on a task, the task moves from a submitted state to working state. So that's the next state of a task. So this is when the agent is actively processing. And in this case, the agent is also streaming status updates either via a webhook or to the client back and forth. Okay. And then the next state is called the input required state. If you remember, we did talk about human in the loop, which is supported in A2A. So in a case where the agent needs a human interaction or to validate or to clarify certain aspects of the task, the agent needs more information from the user. The task goes into an input required state. The next state is the completed state, and this is when the task has finished successfully. So the artifacts are available and the task has been submitted, or not submitted, but the task has been completed and artifacts have been provided back to the client. And then you also have a failed state. So the failed state is when the task encountered an error and as a result of that can be completed. And then you also have the cancel state. So the cancel state is when a task is canceled by a client as well. So no further updates. And when a task is canceled, any push notifications that have been previously scheduled are automatically canceled. All right, so at this point, we're going to move into our demo. And here we have an A2A flight attendant. And the flight attendant is comprised of, let's say, a client application. And the client application is what the user interfaces with, or the command center for the user. And then we have an A2A server as well. The server is the expert, that's a specialist in terms of finding available flights and also publishing push notifications to the client when there's a change in price. So if you think about a flight, someone who wants to travel, I'm going to be flying soon. So I need to find available flights from my source to destination. That's the use case we're building for. And so when the client sends a request to the server, who is the specialist when it comes to flights, is able to find available flights for the user based on their query and sends that back to the client. And then it also subscribes the client to a push notification such that whenever there's a change in price, okay, when there's a price change, it's able to push that price change over the wire via push notification to our webhook endpoint, which is running on the client. So that way the client stays updated. So you can think about you booking a flight and you're constantly getting notifications whenever there's a cheaper price for the flights that you're interested in. All right, so let's get to it. So here, I'm just going to give you a quick overview of what the code looks like. So here in this A2A repository, and by the way, I'm going to link the code in the comment section. So if you're interested in taking a look at the code, just go to the Git repository and you'll have all of that. So it's comprised, first of all, of a client. This is an A2A client. In this case, we're using the A2A TypeScript or JavaScript library. So A2A JS SDK. Okay, and in this case, in our client, we just have the main client code and an index.ts file, and then we have a webhook.ts file as well. Now, the webhook.ts is what includes the code that subscribes to our server, so we're able to get push notifications when they are published as well. Okay, so now with that out of the way, let's go ahead and start our webhook. To run our webhook, we're just going to run npm run webhook. Now, this is a client. The webhook runs in our A2A client. You can see client webhook.ts file. And there we have our webhook running, and it's exposing the /webhook endpoint. Okay, now that we have the webhook running, we're going to go ahead and start the A2A server as well. npm run server in this case. I'm going to run npm run server. And that should start our A2A server as well. Now, in case you're curious what the A2A server looks like, I can show you. It's also just a simple TypeScript file that's implementing the A2A protocol. So you can see we importing the necessary libraries we have here from the A2A JS SDK. And then we're just setting up our agent card. If you remember what we talked about agent card with the necessary fields and all of that, which you'll see in a moment. So, but if you're interested in the finer details of the code, you can find it in the Git repository. And I'm also going to be publishing a skill. So if you want to implement A2A protocol in any of your applications, you can just import that skill and then tell whichever coding agent you're using to just implement A2A protocol for you between your agent, and it will be able to handle that. Basically, you don't even need a skill for that, but I'll have a skill in the repository in case you need it. Okay, so now that we have our server up and we have our webhook endpoint running as well, finally we can start our client. So before I start the client, I should mention this. When we start the client, if you remember, the first step is a discovery, and we'll see that next. So I'm going to run npm run client. Now, when the client starts up, you can see it does a discovery of the A2A server and it's able to discover that the A2A is running on 41241. Now, if I go back to the A2A server logs, you will see that a discovery was made because you can see here in the logs that a discovery request came in for the agent card, which returned a 200, and the response includes some important fields around the name of the agent, version, provider, if it supports streaming, push notifications, and the skills that are available to it. So this is what's in the agent card. So all you see here is coming from the agent card JSON. Now in A2A, I don't know if I've mentioned this, there's an assumption that your A2A server always publishes its cards in the /.wellknown/agent card.json. So that's just an assumption in the A2A protocol specification. So if you're implementing an A2A server, it should support that as well. And then you have another discovery call made, but it's the same, multiple requests happening at the same time. I'm not sure why, but then it's for the same information as well. So it's able to retrieve that. And in the client logs, we can see that it got that information from the server. You can see it's connected to A2A agent, and we can see the flight deals agent, the version, the provider, printed here, capabilities, and skills available. And it has information as to what those skills can do, so it knows when to call the A2A server. So I'm just going to copy this so we can use this as a query sample actually. Now this calls a live Gemini model to retrieve flight information. So I'm just going to paste this here. Find flights from Lagos to London next month under $800. And now I submit a task. Now let's take it one step at a time and see what's happening. The first thing here when I submitted my query is it changed to a submitted state and we got a tax ID. Where did that come from? Well, let's go back to our A2A server. And we'll see here in our A2A server logs that when it received the new query, it classified it as a new task because the task didn't exist before now. And so it received that message, assigned a tax ID to it, and then responded back to the user with a status. And this is tax submitted state, which we talked about, right? And then it continued to publish notifications to the client based on the status of the task. If I go back to our client here, we can see it's changed the task from a submitted to a working state, and it received a status as well. So this is when the server started searching for available flights. It continued to publish push notifications to the client as well, analyzing routes and prices, compiling results. This is when it finally found the information it needed. Then it published the flight information to the client. So here we're just printing verbosely the output or the response from the server. And that's from the task switching state as well. When it received the information, it got to a task completed state where it published flight deals to the client. And the client displays those flight deals here like we see. Now these are parts of a message, right? So these are artifacts or deliverables from the A2A server to the client. And the task changed to a completed state because the task is now complete. And you can see here our push notifications endpoint is still active and it's watching for price alerts. So, and this is all connected and happening in real time. So in the event that there's a price change, our webhook endpoint is going to receive that immediately and it will publish it, right? So we can see our webhook endpoint here running on the client and we're getting information. And the flight search here was completed. Push notifications for that task is also published here in our webhook. However, whenever there's a price update, that will also publish via open push notification. So in this case, we don't have to keep the socket connection between the client and the server open, and that's why we have a webhook endpoint. So TCP is only active for 60 minutes or something like that. So, but you can have the server consistently publish or keep the client updated on new changes. So this is how agent-to-agent communication with A2A can help you optimize your architecture. You don't have to do a polling mechanism where maybe you have a client from the UI consistently polling the server for updates. you can just implement a webhook with A2A supported natively, and you get that feedback. So that's it for this video. We've seen how A2A is implemented from agent card discovery, task lifecycle, the streaming response process, SSC, and how that works, structured artifacts that we get as a response or output, how push notifications work as well, how you can set up a webhook and interact with that server and get updates. So if you haven't hit the like and subscribe button, please be sure to hit the like and subscribe button for this video so you keep updated whenever I do walkthrough videos like this. So if this is your jam, please hit the like and subscribe button. Keeps me motivated to want to keep doing videos like this for you guys, and I appreciate you being here, and I'll see you guys in the next one. Bye for now. Ciao.